Have you ever just stared at a map of Europe's railways? It's this incredible, intricate web that looks like one giant single system. But for the longest time, it was the complete opposite. So we're going to dive into how Europe's trains all learned to speak the same language. It's an amazing story of engineering, a little bit of diplomacy, and a massive, invisible rulebook that controls literally every single millimeter of the track.
It seems like a pretty fair question, right? Why can't a train built in Spain just keep going all the way to Poland? I mean, the tracks are there. But for decades, the moment a train hit a border, pretty much everything had to change. We're talking different power supplies, conflicting signals, even the width of the tracks themselves was different. This was the core problem that European rail had to solve.
And this really shows you the scale of the change. I mean, think about it. We went from a past where every country was basically its own little railway island, completely fragmented, to today where you can just glide across borders without even noticing. Getting from that tangled mess to one connected continent, well, that took a pretty radical idea, creating a common language for all trains.
And that common language, it came in the form of this massive, unbelievably detailed rulebook. This thing is the secret sauce. It's the invisible engine that makes the whole system work. And the official goal behind it all was to achieve this one critical concept: interoperability.
Okay, interoperability sounds like a super dry technical word. I get it. But just think of it like this. It's the universal adapter for Europe's entire rail network. It's the promise that a train built in Germany can plug into the power grid in France, understand the signals in Belgium, and ride perfectly on the tracks in Italy, all without missing a beat.
So how do you make that happen? With these things: the technical specifications for interoperability, or TSIs for short. This is the official name for that invisible rulebook we've been talking about. If interoperability is the language, then the TSIs are the grammar, the vocabulary, the whole dictionary. And they are mandatory, legally binding documents that spell out exactly how everything, and I mean everything, has to work.
And the scope here is just huge. The TSIs are basically a complete blueprint for a machine the size of a continent. They cover every single subsystem you could possibly think of, from the physical tracks and the trains themselves, to the energy grids and the signal systems, and even the data networks that handle your tickets and tell you if your train is delayed. It is a total top-to-bottom rulebook.
So, okay, let's start with the stuff you can actually see and touch, the hardware. How on earth do you get these massive machines weighing thousands of tons and built in different countries over many decades to all physically play nice with each other? Well, this is where the TSIs get incredibly specific.
And that is not an exaggeration. When you've got a train hurtling along at hundreds of kilometers an hour, the difference between a perfectly smooth ride and a total disaster can literally be a couple of millimeters. The TSIs are obsessed with this kind of precision, and for a very, very good reason.
Just take a look at this table. This specifies the exact distance allowed between the backs of a train's wheels, with a tolerance of just a few millimeters. This back-to-back distance is absolutely critical. If it's too narrow, the wheels could drop between the rails on a curve. Too wide, and they could get jammed in a switch. The TSIs define these tiny measurements for every kind of track, making sure any certified wheel fits on any certified track, period. So once the wheels are sorted, you gotta connect the cars together. The TSI for the trains themselves, the rolling stock, mandates a standard universal handshake for the couplers. This makes sure that a locomotive from, say, Poland can safely hook up to a passenger car from France, linking not just the heavy steel, but also the critical air brake lines in a way that's totally predictable and safe. And what about power? That comes from the pantograph, that arm that reaches up from the top of the train to the overhead power lines. The TSIs dictate its exact shape, the materials it can be made from, and its precise working height. This guarantees that as a train flies from one country's power grid to another, it can keep drawing electricity smoothly and safely without a single flicker.
And of course, stopping is just as crucial as going. The TSI rules for brakes are, as you'd expect, incredibly strict. The main brake has to be continuous, which means when the driver hits the brakes, that signal travels down the entire length of the train instantly. And it has to be automatic. This is a brilliant failsafe. It means if the control line ever breaks, the brakes turn on by default. It's all about building a system you can count on, no matter what happens.
But getting all the heavy metal to work together is really only half the story. A truly modern, interoperable system also needs an invisible network, a web of data and rules that are focused on the passengers. And this is where the telematics TSIs come into play.
Have you ever booked a train ticket from, say, Paris to Berlin? The magic behind that simple click is the telematics applications for passengers, or TAP TSI. The moment you search for that ticket, a standardized request shoots out across a massive network, checking for available seats with different train companies in real time. It finds a path, assigns you a seat, and gives you one single ticket that every conductor on your journey will recognize. It's this complex data ballet that happens in just a few seconds.
And that system does way more than just sell tickets. It's the same network that powers those real-time updates you see on the departure boards or on your phone. You know, when it says your train is running 5 minutes late? That's a train running forecast message being sent across the network, making sure everyone, from you to the station staff, has the latest info.
Beyond just data, the rules are deeply focused on people. The TSI for accessibility shows that this was never an afterthought. The rulebook gets down to the millimeter, mandating door widths, the turning radius for wheelchairs, where handrails have to be, all to ensure the entire network is a genuinely public system that's usable and welcoming for absolutely everyone.
So we've got this incredibly complex, continent-wide rulebook. You might think, okay, great, they wrote the rules, job done. But not even close. The work of making everything interoperable is never really finished. This rulebook has to be a living, breathing document that's constantly changing with technology.
And this timeline really shows you how dynamic it is. The TSIs are always being revised, updated, and improved to keep up with new technology and lessons learned from the real world. This constant evolution is what keeps the system safe, modern, and efficient. I mean, the updates in 2023 alone made changes to almost every single part of the system.
And here's what's really brilliant. The rulebook is actually designed to encourage innovation, not block it. This quote right here is key. It basically creates a formal process for a company to come forward and say, hey, we've invented something new that doesn't quite fit your rules, but it's better. It ensures the system can adapt and bring in the next big thing in railway tech without ever compromising on safety.
So what's the big takeaway here? The next time you're on a train and you glide effortlessly from one country to another, just remember the invisible engine that's making it all happen. It's not magic, it's this enormous, detailed, and constantly evolving set of rules, the TSIs, that lets hundreds of different pieces of a puzzle act as one beautiful, unified system.
And that leaves us with one last big question. We're heading towards a future with even faster trains, fully digital signals, maybe even trains that drive themselves. The huge challenge for the next generation will be to make sure this invisible rulebook can adapt all over again, to build the railways of tomorrow.